Hi and welcome to another tutorial video. In this tutorial video what I'm going to be doing is talking to you about graphs. So what is a graph in computing? Well, the definition I've got here is a graph is a set of nodes which are sometimes also called vertices, which are connected by arcs, and they're sometimes called edges. So it's a set of nodes connected by edges, and what a node is a point on a graph which represents something. So, for example, it might represent a town, and an arc is a line that connects two nodes and is a means of representing a way of moving between the two nodes. So, for example, a arc might represent a road between two towns, and the towns are the nodes. The arcs in a graph can be uni or bidirectional depending on the type of graph. So a digraph has unidirectional arcs, and that means that you can only move along an arc in a single direction. And an undirected graph has bidirectional arcs. So in an undirected graph you can move along the arcs in either direction. And a digraph is sometimes also called a directed graph. The arcs are directed, meaning that you can only move in the direction indicated along an arc in a digraph. Arcs can also be weighted, so an arc may be weighted to represent the fact that there is a cost associated with moving between two nodes. For example, the arcs in a graph of towns and roads may be weighted to represent the cost of the fuel required to move along a road between two towns in a car. Okay, let's take a look at some of the applications of graphs. So what are graphs actually used for? Well, I covered one application of a graph a minute ago. You could use a graph to represent a road network, so with each node being the towns in the road network and each arc being the roads between the towns. Some other examples of how you could use a graph is in representing a computer network. And here the nodes would be the computers in the network, and the arcs would be the cabling linking together the computers and the other devices in the network. You could use it to represent states in a finite state machine, and here our states would be the nodes, and the arcs would be the transitions between the states. You could use a graph to represent tasks in a project where the nodes are the particular tasks to be done, and then the arcs, possibly weighted with a time required to move from one task to another, would represent the transition between two tasks. You could use a graph to represent web pages and the links between them, so you could have each node be a particular page, and the arcs representing whether or not there is a link between two pages. My final example is that you could use a graph to represent lines between railway stations, where each node is a particular station and the arcs are the lines between the stations. And I'm going to show you a very popular example of how that has been done in the real world. Okay, so you'll probably recognise this map here, especially if you're from the UK. This is the map of the London Underground network, and you can see that this is a graph like we've been talking about. Each station, for example Oxford Circus here, is a node in the graph, and then we have the arcs. For example, this arc here is indicating that there is a route directly from Oxford Circus to Green Park. So here are the nodes. We've got all of our stations with their own node, and we've got the arcs representing the fact that there is a line between stations. Okay, so that brings us to the end of this tutorial video, an introduction to graphs and what a graph looks like with this popular example. I hope you found this tutorial video useful, and thanks for watching.